In March 1962, the first OG system in the world started operation at number 2 BOF plant of Nippon Steel Corporation's Yawata Works. Since then, its superb performance has attracted worldwide attention. The OG process has since been widely adopted. As of March 1976, as many as 108 OG systems were in operation or under construction in 13 countries. Annual crude steel output from BOF plants equipped with the OG systems will amount to 120 million tons by 1977. Now let's take a look at the BOF and OG operations in Oita BOF plant of Nippon Steel Corporation. The carefully designed hood is an important element in the maintenance of a clean plant atmosphere. It collects all the fumes generated when discharging the hot metal from the torpedo ladle, charging it into the converter vessel, blowing and tapping, and feeds them into the secondary ventilation system. To achieve the most effective design, the ventilation hood profile, gas flow rate to be sucked, and other factors are studied. Many model experiments are conducted. Thus, the steel-making plant no longer emits dust. The plant interior is always kept clean, greatly improving the working environment. Now the OG system is started. Ignition. The inert gas produced by intentionally burning gases coming out of the converter vessel during the early and late periods of blowing purges the whole OG system. The entire OG operation is completely automated after the start of blowing by the simplified instrumentation system. As the need for more effective utilization of energy increases in recent years, collection of OG gas has been attracting global attention. The system's capacity to collect OG gas has increased greatly. Today, more than 70 normal cubic meters OG gas per ton of steel with a calorific value of approximately 2,000 kilocalories per normal cubic meter can be collected. This improves the BOF's thermal efficiency by 20% or more. Further, it introduces a major improvement in the energy balance of the entire steelworks. This OG gas, containing a little SO2 and NOx, is extensively used as a pollution-free fuel. In the steelworks, it is used in lime kilns, chemical plants, power plants, process boilers, reheating furnaces, soaking pits, hot stoves, coke ovens, pelletizing plants, and so on. Also, part of it is used as an industrial material. The noise level of the OG system is successfully held below 60 phons at any location in the plant. The water recirculation system eliminates water pollution. Also, the OG system presents no problem as to air pollution, making the system perfectly pollution-free. To meet stringent environmental requirements, many conventional waste gas treatment systems have been remodeled to the OG system, as in the case of the BOF plant at Nippon Steel's Nagoya Works. Since then, the OG system at Nagoya Works has been operated at a dust concentration in the waste gas of 50 milligrams per normal cubic meter in dry state or lower. At this BOF plant, the sublance system measures the bath temperature and carbon content during the blowing. The subsequent blowing is dynamically and automatically controlled based on the information thus obtained. This permits the so-called one-touch operation system involving no manual operation during the blowing. From time to time, the bath temperature and the carbon content are displayed on a cathode ray tube. When they come within the target ranges, the blowing is automatically stopped. In the case of plain carbon steels, the stopper blowing is immediately followed by tapping, without any sampling and temperature measurement. This is number 1 BOF plant at Yawata Works. The maintenance-free OG system is applied to this BOF plant, where the vessel exchange type converter of 150-ton capacity is adopted. It permits continuous operation with very limited downtime. Since its startup in June 1974, this plant has already registered 25,000 consecutive heats. On the other hand, at number 3 BOF plant of Yawata Works, the two converters of the vessel exchange type have accomplished respectively 120,000 continuous heats during the 10-year period since 1966. Time required here for the vessel exchange is only 4 hours. At this plant, the whole OG equipment is arranged in the plant building improving the layout flexibility of the system. To satisfy the customer's requirements, new operator-minded improvements are continuously added to the OG process based on our extensive operational experiences. The engineers of the design and manufacturing divisions make cooperative studies to better realize such improved designs in the equipment. According to the carefully prepared designs, the OG equipment is manufactured at the Chiba works of Kawasaki Heavy Industries Limited in Japan. Membrane panels that make up the gas cooler, one of the major components of the system, are manufactured by the highly automated process. Skilled workers assemble components into the skirt, hood, gas cooler and other units. This makes up an economical, high-quality system. The completed equipment is shipped from the works quay to domestic and overseas customers. More and more big steel manufacturers are introducing this OG system throughout the world. In the United States, at Inland Steel, the OG system has been operating smoothly since Chemical Air Pollution Control Company completed its installation in August 1974. BOF operations are controlled in a modern instrument-filled room adjacent to the vessel. The operator moves the vessel into an upright position after receiving the hot metal charge. The OG system has its own separate control area located just above the main control room. Here the operator utilizes television monitors and the latest instrumentation to coordinate the OG system with the main steelmaking operation. After blowing has been completed, the OG operator raises the hood. Escaping fumes are captured by the secondary ventilation system. American engineers have a high opinion of the system. The Appleby Frodingham BOF plant of British Steel Corporation, Davy Ashmore International Limited installed 3 OG systems on 300-ton converter vessels. Since May 1973, they have been operating smoothly. At this plant, a pressurized water cooling system is adopted for the gas cooler. OG system is highly rated by the technical staff of British Steel Corporation. Many new BOF plants for the OG systems are erected and under construction in Brazil. Here, Volta Redonda BOF plant of Brazilian National Steel Company is one of them, and Kawasaki Heavy Industries Limited supplied them with the OG system. The gas recovery system. This is the first gas recovery type OG system in South America. The installation of the OG system is now on the final stage, and it will start very soon. Taking advantage of the opportunity in which OG orders exceeded 100, the OG family conference was held between March the 29th and April the 7th, 1976. In an effort to satisfy the requirement of the customers, the participants discussed further improvements of the OG process. In addition to this conference, the OG family members frequently exchanged technical information so that the comprehensive technique of the OG process can be raised to higher levels. At Kimitsu Works, many visitors and trainees admire the OG system that stands more than 10,000 heats, requiring very little maintenance during its 1 year or longer service life. In Japan, the most up-to-date BOF plant of Nippon Steel is open to OG process visitors and trainees. Here, the ties of international friendship are strengthened through earnest and frank discussions on the OG system. The OG system, jointly developed by Nippon Steel Corporation and Kawasaki Heavy Industries Limited, is making increasingly greater contributions to the steel industries of many countries as it spreads throughout the world.
Steel mills were once characterized by chimneys belching steel-making furnace gases. The OG process for waste gas handling has changed all that. Economical to build, reliable in operation, and efficient in that it offers financially sound waste gas utilization, the OG process is a modern method of handling BOF plant gas. the Kimitsu Works of Yawata Iron and Steel Company. Located on the eastern coast of Tokyo Bay, this works started operation in November 1968 as one of the most modern integrated steelworks in the world. Its BOF plant. Operating here are two 250 metric ton or 275 net ton basic oxygen furnaces equipped with the latest OG installations. If carbon monoxide generated in the vessel could be recovered without burning, many advantages would be derived. Based on this idea, the OG process has been developed in Japan as a joint research project of Yawata Iron and Steel Company and the Yokoyama Engineering Company. Here are the highlights of the OG process. Carbon monoxide generated in the vessel is sucked out through the hood in such a way as to prevent leakage from the vessel mouth. Then the gas is saturated in the quencher where coarse dust particles are collected. The remaining finer dust is removed in the venturi. The cleaned gas is either discharged into the atmosphere through the flare stack or recovered into the gas holder through the three-way valve by means of the induced draft fan. The numerous advantages of the OG process have been amply proven by the installations already operating in various BOF plants. Let us watch some of them in actual daily operation. Scrap charging, metal. The blowing begins. In the OG process, once the blowing start button is pressed, all of the operations are carried out automatically, so no special OG operation is necessary. With the OG process, gas handling operations never interfere with steel making operations. Ignition. When ignition of the generated gas is confirmed, The skirt is lowered onto the vessel mouth. Hood closing, combined with hood pressure control, can prevent air from leaking into the hood and limit combustion to a low level. Compared with conventional full combustion gas handling methods, the OG process has many advantages, namely, the cooler and dust collector are more compact, operating and maintenance costs are cheaper, tapping yield is increased, and useful gas can be recovered. Since gas cooling and dust collecting are accomplished with the gas in an unburnt state, the gas volume to be handled is less than 1/4 that in conventional processes. This radically reduces the sizes of the cooler and dust collectors. The gas leaving the cooler at about 1000 degrees centigrade or 1800 degrees Fahrenheit is further quenched and cleaned as it passes through the quencher and venturi. The venturi has a movable throat, the opening of which is automatically adjusted to accommodate the fluctuating volume of the passing gas. The movable throat keeps constant gas velocity through it. At the same time, it adjusts the pressure inside the hood. This enables the OG process to operate with stability and efficiency throughout blowing. Since the gas is treated in the unburnt state, the dust particles are coarser and much easier to collect than in other processes. At the outlet of the venturi, the gas is as clean as less than 0.05 grams of dust per normal cubic meter or 0.02 grains per standard cubic foot. OG dust is precipitated in the thickeners and recovered by the press filters. The OG dust recovered in an unburnt state is low in the degree of oxidation and thus high in ferrous oxide, ferrosulfuric oxide and metallic iron content. This makes possible multi-purpose utilization of the OG dust. It is particularly sought after for pelletizing, briquetting, and sintering. Increased yield in steel making is another feature of the OG process. The closed hood process can save the iron loss due to sloping and spitting of the molten bath. This increases the tapping yield by more than 1% over a conventional open hood process. 5 minutes after ignition. When carbon monoxide concentration in the gas exceeds a certain set value, the three-way valve is automatically shifted to the gas holder side so that CO-rich gas is recovered in the gas holder. The calorific value of the recovered gas ranges between 2,000 and 2,300 kilocalories per normal cubic meter, or from 213 to 244 British thermal units per standard cubic foot. The OG gas can be extensively employed as fuel. It is an excellent fuel for boilers, for hot stoves, it is also used in heating furnaces, soaking pits, and since practically no hydrogen is contained in the OG gas, scale loss can be substantially reduced. The OG gas has no sulfur in it either. This characteristic makes it a highly suitable fuel for lime kilns and pelletizing kilns. The OG gas can also be utilized as a raw material for synthetic chemicals. It can be used to advantage for the synthesis of methanol, urea, formamide, and other chemicals. Yawata Chemical Industry Company is now using the OG gas recovered from Tobata OG for synthesizing methanol. "15 minutes after ignition, the operation proceeds smoothly. Easy computerization of steel-making operations. This is another advantage, since the OG process facilitates computer control. The accuracy in estimating decarburization of the molten bath by analyzing exhaust gas is definitely increased with the OG process, as unburnt gas offers more dependable data. This method now enjoys an established reputation. However, the OG process also works perfectly well without a computer. When the end point of blowing is determined visually by flame conditions, this can be done simply by lifting the skirt. "18 minutes after ignition, the time for tapping. First, the molten bath temperature is measured. Sampling. And now tapping. It was in March 1962 that this OG process was first adopted at Tobatan No. 2 BOF plant of Yawata Iron and Steel Company. Since then, 17 OG-equipped basic oxygen furnaces have been built. In all cases, the OG system has given excellent results. As of March 1969, these 17 furnaces had produced a total of more than 55 million net tons of steel. During the intervening 7 years, many improvements were made in OG design and operation. One such innovation was the constant dry gas control. This method is based on the idea that the dry gas flow rate should be controlled constant, thus automatically causing a naturally controlled combustion sequence. This makes it unnecessary to modulate the set point of hood pressure. The operator merely adjusts the skirt position to obtain the desired ventilation effect without disturbing the degree of controlled combustion. This further simplifies the OG operation. The compact, durable and reliable OG equipment can remodel an old open hearth plant into a modern BOF plant economically and quickly. Here in Yawata's Higashida BOF plant, 2 BOFs have replaced 5 open hearth furnaces. The use of the OG process is not limited to Japanese BOF plants. Several OG installations are now in planning or under construction in other countries. The BOF plant in the Middletown works of Armco Steel Corporation. For the first time in the United States, this plant will have 2 OG-equipped 180 metric ton or 200 net ton basic oxygen furnaces. It is now under construction and is scheduled to start operation in May 1969. A second OG installation for another American steel company is now in the designing stage. And this is the Abbey Works of SCW Division of the British Steel Corporation. Two 275 metric ton or 300 net ton furnaces with OG equipment will begin operation here in July 1969. Several other OG projects are currently being negotiated, and prospects are that still more OGs will soon be built at home and abroad. Unrivaled in economy and efficiency, the OG process is the converter waste gas handling method of the future.